Today we graph sine and cosine functions, but instead of just doing 2 transformations, we're going to do 4. So for example, earlier we did amplitude and period. Today we're going to add to that horizontal and vertical shifts. So for example, we've looked at, say, y is equal to -4 sine of pi x. Today we're going to change that. Instead of looking at those 2 things, we're going to look at y is equal to -4 sine of, say, pi x minus 1 plus 8. So it looks complicated. It really does. And this is the most challenging part of the unit. But the nice thing is, if you can do this, then the test is pretty easy. If you can't do this, then Wednesday's lesson becomes even more difficult. So here we go. There's a number of ways to teach this. Over the course of my 20-plus years of teaching this concept, I think that this is the best way to do it for most people. If you find a shortcut around something, you like to do something different, then you go ahead and do that. But that's kind of one of the challenges of teaching is I teach everybody at once, right? And I would say that 2/3 of the time I teach something, I did it differently when I was in high school. So the way I teach isn't necessarily that I would do it. So if you have a different way, always, please welcome, go ahead with it, okay? The amplitude is still always the absolute value of A. Who remembers the formula for period? 2 pi over b. The vertical shift is the number on the outside, okay? It's the number on the outside, so it's that d value. So maybe remember that unit where we talked about outside is vertical and inside is horizontal from earlier this year. So the horizontal shift has to do with this inside. We set bx minus c equal to 0 and we solve for x. That's it. Yeah. Yep. So I like to, you have 4 different things going on. So it's kind of like, how do I organize it? And I personally, I really like, and this is one of those things where I mean, the way that I did in high school is how I'm teaching it. I just think that this works best. And so I like to start with the vertical shift. I think that's the best place to start. Then the amplitude, then the period. And I take a break at that point. But these 3, that's where I start. So we're going to do letter B to start here. And what is the vertical shift for letter B? It is 2. So that means that the entire graph is shifted up 2 units. So instead of being held on the x-axis, it's up 2 units, 1 and 2. What is the amplitude? 3. So from that spot, we would go up 3. And we would go down 3. So this is the part that people get most confused about, it seems, with this step, is that they don't understand like what the max and min are. If you saw amplitude of 3, then you would say, well, 3 is the top and -3 is the bottom. Well, that's all shifted 2 units. So you do 2 plus 3 to get 5 and 2 minus 3 to get -1. Everybody okay with that? All right. So then we do the period. Take 2 pi and we divide it by the number in front of x. What's the number in front of x? 1. So the period is just 2 pi. So I'm going to mark off 2 pi. Pi. Pi over 2, 3 pi over 2, and as you said, there is no horizontal shift. So as you notice, there's nothing sitting in your parentheses around the x. So here I do have a horizontal shift. Here I have a horizontal shift. Here I have a horizontal shift, but I do not have one there. Okay. So I went vertical shift, amplitude, period. There's no horizontal shift. Don't need to worry about it. And so where does cosine start? Yeah, all the way at the top, not at 3, but at 5. It's going to start at the maximum value of the graph. And just to make sure we see this, watch what happens here, Kenny. The cosine of 0, do you remember what the cosine of 0 is? 0, what's the coordinate there at 0? Cosine of 0 is 1, because that's the x value. Everybody see that? So cosine of 0 is 1, multiplied by 3 is 3, plus 2 is 5. So you could just always say every time that cosine will start at the maximum. But that's why, okay? And then it drops, goes to the bottom, comes back up, goes to the top. Go ahead and look at your peers' graphs, maybe even judge them. Do they look better than yours? Do they look worse than yours?
You don't have to. Don't have to. I just loaded like this because I think this is making big slides. That's fine.
Okay, but so you would.
I know that's 5 total.
Okay, got it. I would not know that if I was looking at it. So, yep. Okay. So sometimes people ask, well, is my graph, does it look nice enough for the test? And every once in a while, I'll get a graph that looks like this, and that's not sufficient. If you notice here, I go way below -1, I go way above 5. So try to keep your graph within reason. Try to make sure that its max is its max, its min is its min. I try to be pretty forgiving in terms of how, like what does the curve look like and stuff. But when you start going out of bounds, every once in a while, I'll even get one that looks like this. And and people come back, they're like, well, you said you didn't care how neat the graphs were. And I said, well, I said I to some extent, but I said I can't understand. They're like, well, my work's just sloppy. I'm like, okay, your work's sloppy. Like I don't, it's like we're going off to college. Let's try to draw neat. A little bit. So anyway, so for the most part, I think everybody should be good. But if you've got really bad graphs, let me know, and I'll tell you whether or not I can understand it. Okay. All right, let's try this one. I have amplitude, but first we'll do the vertical shift. Anybody see what the vertical shift is here? Yeah, there's nothing on the outside here, so there's no vertical shift. The amplitude is 1. So that means I'm going to go to a height of 1 and down to -1. What is the period? 2 pi. See that? Yep, the number before the x. So I'm going to mark off 2 pi, pi. Put a negative there, my bad. And where are you going to start? Yeah, we start at 0. Now here's the deal. Anytime I have a horizontal shift, which I do in this one, I stop after the period and I sketch a ghost graph. That's what I call it. I think that this helps people visualize what's happening better. So I'm going to sketch a graph of the sine function as though it doesn't have a horizontal shift. And then I'll apply the horizontal shift. Does sine start at the max, min, or middle? And is it going to start by going up or down? It is going to start by going up. And instead of drawing a connected graph, I will draw a graph that is dotted, just so I can get a general feel for what it looks like, because this is not my real graph. This is not my end result. It's just something I'm going to use as a basis for making my transformation. So how do I determine the horizontal shift? We take the inside and we set it equal to 0. So x minus pi over 4 is equal to 0. If you solve x minus pi over 4 equals 0, what do you come up with? Pi over 4. So what that means is the entire graph is going to shift pi over 4 units to the right. If it was a negative pi over 4, it would shift pi over 4 units to the left. Now, how much is pi over 4? How does pi over 4 compare to pi over 2? It's half of pi over 2, right? So we're just going to take these marks and we're going to move them half of a unit to the right. You can notice that if I grab this graph and just pull it back, it maps perfectly onto that previous graph. So you can see very nicely the change. Okay. Letter C. Now we're going to put all 4 of them together. Vertical shift, -2. Amplitude, +4. So if the vertical shift is -2, does anybody know what the highest spot of the graph is going to be? +2. How come, Izzy? From -2, you go up 4 units. That brings you to 2. And if you go from -2 down 4 units, it brings you to -6. So +2 is the highest point of the graph, and -6 is the lowest point of the graph. So I have -2 right here. I go up to +2. I go down to -6. That's the vertical structure of my graph once I have that laid out. I always start by laying out the vertical structure. What is the period? 2 pi divided by pi. Divided by pi is equal to 2. So I'll mark off 2. Divide it in half to get 1. 1/2. 3/2. Where should I start? Down at -6. I will go up. That is not my actual graph. That's a ghost graph. I'll use that to be able to determine the real graph. But first, I must determine the horizontal shift. How do I do that? Pi x minus 1 equals 0. Add the 1, I get pi x equals 1. Divide by pi, x equals 1 over pi. Now, I don't have a mark up here that tells me what 1 over pi is. If I go to my calculator and I turn it on and I take 1 divided by pi, I get 0.32. So 1 over pi is 0.32. How much does 0.32 compare to a tick mark? It's a little bit more than half of a tick mark, isn't it? So I'm going to move it just a little bit more than half of a tick mark to the right. Okay, last example. I've done the first few. You guide me. Where do we start? Up 3. Then what? Your amplitude is 1. So what does that mean? Max of 4, minimum of 2. So the entire sine graph is going to stay between the values of 2 and 4. It's not going to drop down to the x-axis at all. Now what? Period is 2 pi divided by 2, which is pi. Before I do the horizontal shift, I'm going to sketch a ghost graph. Where do I start? Right in this middle. Will I be going up or down? Down because it's a negative sign. To determine the horizontal shift, 2x minus pi over 2 is equal to 0. 2x is equal to pi over 2. Divide by 2, what is pi over 2 divided in half? Pi over 4. Pi over 4 is your horizontal shift. Pi over 4 is the same as 1 tick mark. So you can take all of these and move them over 1 tick mark. How's the turkey sandwich today, Rach? Use mayo or mustard? I'm a believer that mayo, mustard, and ketchup belong on things like hamburgers. When it comes to a sandwich, I just want my meat and cheese. Can I give you a hint? Okay. So, watch this, Caitlin. So, if I take this point and move it over there, and take this point and move it over there, I now have enough to create a pattern. Watch. So, I don't necessarily have to do every single one. I can do this. I can move this over one spot and this over one spot. Do you see the pattern now? So I'm going down, so now I can come back up and up. Now I'm not moving dots, I'm just placing dots. See what I'm saying? Yeah. So you can place instead of move, and that sometimes helps people. Okay, so your assignment. You're given time to work on this tomorrow, but you do not need to do example 1 and example 2. We will use one or both of those as a checkpoint. The actual problems 1 and 2, definitely want to do those. And then 3 and 4, this should be your second assignment from this unit. Don't need to do example 1 and example 2. So on the first 2 pages is problems 1 through 6. And then please do note that problems 9 and 10, you're asked to graph 2 of them on the same axes so you can see the difference. That should help you with your graphing expertise. And yeah, you're gonna be. So we will do a little bit of. I would say about 30 minutes tomorrow will be devoted to work time. About 15 minutes will be us trying a couple problems together.